All right. Well, welcome to Innovate 2026, and welcome to the IoT Connect portion of Innovate 2026. As you can see from the title there, essentially what we're going to try to illustrate to all of you folks today is the way you garner value through AI and IoT technologies. So we've got a group of experts up here to talk to you about that today. We'll end with some Q&A, so if you guys have questions, I'll open the field up for questions and let this group of guys answer them for you. I'm Josh Becker. They're on the far right, your left, I guess. So I run the IoT commercial team, essentially a global team of business development executives, building IoT ecosystem partnerships, building new solutions, and taking those to market through a variety of go-to-market models. And I also lead the industry consulting team in the Industrials and IoT division. Been with SAS about 15 years. I was a SAS customer for 12 years prior to that in the manufacturing space. So I've got a lot of SAS experience. I'm from Wisconsin, so if anyone wants to talk about Wisconsin or analytics and technology, hit me up. Brian Saunders here to my right leads our global industry consulting team. I'll let each of these guys introduce themselves a little deeper when they get up. Saurabh leads our product strategy group, and Dave Froning leads our product management group. So today's agenda, we're at the kickoff section right now. Brian's going to talk to you guys all about sort of the state of the union in the industry, how AI and IoT are being applied to real-world applications to drive value. Dave Froning is going to go through our portfolio in action, give you a flavor of all the things that we do and take to market, purpose-built solutions for specific industries. Saurabh is also going to go through some of the more recent innovations that we've developed. Our group is constantly innovating and bringing accelerators to market, service packages to market, small solutions that leverage the latest and greatest in AI and IoT. And finally, we'll go over the future of SAS in the IoT space and innovations in that area. So there's a lot of content for you all to take advantage of this week. Encourage you to get involved in a lot of conversations. We have, I think, some 600 people from SAS here to support the event, all with a variety of backgrounds in technology, industry, commercial, go-to-market. Our team has put together this little agenda here. If you click on this QR code, which will be coming up several times in the presentation, if you don't want to grab it now, you'll get a curated agenda of all IoT related topics throughout the event to kind of help guide yourself. There is a bit of an overwhelming feeling at these events, and the Gaylord, I'm sure you appreciate this already, is a massive complex that's a little hard to navigate, but this will help you find IoT-related content, no-miss keynote sessions, and networking demos, and some of the fun and entertainment that we have throughout the week. So scan that QR code now, or before you leave, we'll have it up again. The good news is you've started your journey already. You see you're at the IoT Connect. Hopefully that's where you're meant to be. Feel free to come on in from the hallway there. Yeah. You feel free to move to the front of the room. The quizzes the quizzes we have built in are real easy, so don't be afraid to get called on. Again, just to reiterate, get involved, stay connected, try to maximize your time here. This is an amazing event. It was called something else when I was a SAS customer, but I learned most of what I know about SAS through events like this and networking with practitioners and people with big dreams about what they could do with analytics. I've got some pretty interesting stories, but there's so many things that I can think back to early in my engineering career where I said to myself, if we could just harness this data and if we could just process this automatically, man, how much time would we save and how much more efficient we would be and how much better our quality and reliability would be. And we're really at a point in history where all that stuff's coming to fruition. And folks like yourselves that are out there in industry applying AI to your business problems this is a great chance to learn about that and network. Right after this event is the welcome reception, so everybody encourage you to go back down to the hub or go to the hub if you haven't been there yet. We've got a bunch of live demos set up throughout that hub, a bunch of engaging, interactive, immersive activities. That innovation hub will be open all week. We have an industrials and IoT booth there where we're doing some interesting stuff with computer vision enabled worker safety and some other industrial appliances. You'll notice ours has a very large mechanical device at it. It's kind of neat to see even if you're not in that space. There's a brain date lounge, so you can schedule a date with SAS folks to go deep dive on a specific subject if you want. And use your app. So the app has everything in it that you need to navigate yourself around this massive building, find folks, find us. I think, Emily, is our contact information in the app or not? SAS folks? I can't remember. But Emily in the back of the room there, raise your hand, Emily. She is sort of the orchestrator of all things industrial and IoT. So if you need something and you see her, feel free to ask. If you see me or any of the folks up here, we can help get you where you need to go. And with that, I'm going to turn it over to Brian Saunders to start the State of the Industry section of our IoT Connect. Thank you.
All right. Thank you, Josh. So, as do what? I think it's on. Can you hear me in the back? All right, cool. It's going to rip my pocket out here. As Josh mentioned, Brian Saunders, Global Director, Head of Industry Consulting for the Industrials and IoT Division. Like Josh, I come from industry. My background, I spent my first 15 years of my career at General Electric, working with Craig and others around the room. I started out in factory automation and control systems for manufacturing, then moved into the Power Services Division of GE Power, so part of the Monitoring and Diagnostic Center in Atlanta, Georgia. So my team had responsibility for the data and analytic component of our service delivery for the market. So then joined SAS a little over about 12 years ago now, and I've been leading either as a consultant or now leading the global team as part of that journey. So today I thought it'd be good to share a little bit of what I see and what we observed last year of what I would call sort of the State of the Union for industry. And this was a survey that we commissioned. We had done a prior version about 6 years ago. And so working with IDC and TD SYNNEX, one of our distributor partners, to just go out and survey 300 SMB and enterprise organizations across manufacturing, transportation, energy, utilities, to kind of understand where they're at on this journey, what are the challenges, and compare that to maybe where they were 6 years ago to see how technology and how the investments we as an organization are making within IoT, and then we as a bigger SaaS entity are investing in broader AI capabilities. So the nature of the survey was really around this concept of the artificial intelligence of things. And it's this convergence in our world where we're part of an IoT division, but we're also part of an AI and analytics company of SaaS. So it's how do these two technologies complement and drive extended value for enterprise. Now, I don't expect you to be able to read that, but I just wanted to be very clear what IDC defined AIoT as for the purposes of this study. And it's really connected things and AI technology, but I would just call your attention there to the middle. It's for better decision-making, planning, and process improvement. That's really the goal of our division. It's how do we help industry go faster, achieve better results in shorter time periods? And it's us and our partners that we feel like can kind of offer that scalability and acceleration. So I'll just share a few of the kind of the key takeaways because I think they're pretty interesting. About 4 out of 5 people said that AIoT is at least important, very or critically important to their enterprise to remain competitive over the next 3-year planning cycles. And that squares with what we're seeing. I think the reality is organizations are understanding that to maintain that competitiveness, experiential decision making has to be sort of superseded by data-driven decisioning in order to keep your place at the forefront of your industry, your markets. Then within that, we said, well, just because you think it's important, are you investing? Are you putting money behind these initiatives? And 64% of the organizations said they will see at least moderate to significant growth in their investment over the next 12 to 24 months. So one, there is a need, and two, there's an investment mechanism behind it, which is good if you're in a business like AI and analytics. But I think one of the things, and this to me is the big challenge, over half of the organizations that said this is important, we're investing, they're struggling to get beyond sort of the proof of concept to limited pilot deployment. They struggle to scale. Well, if you know anything about SaaS, that's one of, I think, our superpowers. That's an area that we have, I think, perfected over our 50 years. It's doing these things that are really hard, really challenging, but have to scale across large-scale enterprises. So we're finding there's reasons for that, and I'll touch on some of the challenges here, but I think that's a really key point. You're not going to capture that value doing desktop experiments. A data scientist working on his PC, writing a model and saying, hey, I think this model can predict X, but if you can never deploy that model, you're never going to predict X and never achieve benefit. So it's taking that next leap in the distributed deployments. So we challenged them. Well, what are the roadblocks? What are the barriers that you are seeing on this journey? Why only half of you are making it beyond pilot sort of stage? And skills gap was the number one challenge. And that, maybe it's not a surprise, that was number 6 years ago. It's moved up for sure, or number 5, excuse me. And I think that skills gap is twofold. They're definitely seeing it from an AI expertise, those that are familiar with data, how can I better adopt and drive value from analytics, but they're also seeing it from the workforce. Lots of turnover, lots of churn, aging retirees leaving, and so they're now becoming more and more dependent on AI, and they're being dependent on younger workers having to operate with a higher level of efficiency than their predecessors were asked to do at that stage of their careers. Then you have the traditional system integration costs. I come from manufacturing. Again, I'll use a lot of industrial examples. The technology that we'll talk about today can really scale to any enterprise. So bear with me if I use a lot of industrials. Hopefully you can draw that parallel in your mind. But manufacturing, for years, integrating data systems are still challenging. You still have siloed machine tool builders that want to lock away their data, not expose it. And so you get all these different islands of automation, and they're really tough to integrate. And that has become one of the big barriers of how do I overcome that? How do I make the strategic investments to unlock the appropriate returns? The data quality and refresh cycles. I hear this all the time. Everyone's like, oh, I got bad data quality. That doesn't mean you can't get started. Obviously, everything is relative at this point, but there's never an instance where we have found that the data is so bad that you can't take that first step in the journey. So helping organizations on that path. And then as you kind of work through implementation costs, very similar. There usually is an investment in new sensing technology, new hardware, new compute, new storage. Those are all considerations that have to factor into your strategic plan. And then cultural resistance. You can see that was actually number 1, and now it's down to number 6 in this year's study. And I always use stories about my own kids. So my dad and just my family, I'll make fun of us. My dad's an engineer, industrial systems engineer. He is I'm going to go look it up in a book. Like that's his way of problem solving. I'm of the generation that I'm a trust but verify guy. I believe in technology, but I also have a healthy skepticism. Do I trust it? Do I believe it? My kids are blind trust. And my daughter popped a tire in her car. And I asked her, well, how did this happen? Well, I hit a curb. I'm like, well, did you not see the curb? Well, Google Maps told me to turn. I'm like, but it told you to turn where there was no road. I was like, because they were doing construction in that area. The maps hadn't been updated. But she blindly believed in the technology and turned, a couple $100 later of a tire, then my lesson learned, I guess. Teach her how to drive better, I guess. But I think you're now starting to see the workforce is changing, and I think people have grown up dependent on this technology. So I think the resistance is starting to fade away. I don't know if that's a good thing or a bad thing. I think blind trust can be bad. So it's balancing that along the journey. Now we challenged them as well. Like, well, those that have successfully navigated those roadblocks, gotten to the value, where do you see the benefits? And you can see they're pretty, like peanut butter, pretty evenly spread here. Some were very focused on cost savings. Can I do things more efficiently? Can I drive new innovation? Can I do things, maybe more efficiently? Can I build better product? Can I manufacture a product at a lower price point? Just improved operations, better throughput, better planning, better flow, better supply chain, resiliency, and then just overall productivity and competitiveness in the market. So they certainly, I think we're seeing pretty universal benefits, and I don't think these are mutually exclusive. They're usually intertwined as you start pulling the thread. Now, this is the part that I think is pretty exciting. Less than 3% of the people surveyed said that their investments they were making with AIoT did not meet their expectations. So, said in a more positive spin, 97% that made investments saw return, saw value. That's a pretty good, I think, testament to what this can unlock. And then the chart here on my left, your right, those that heavily use AIoT technologies, this AI and instrumentation connected assets, those that heavily use are twice as likely to see returns and see benefits. So we definitely see the industry is showing that correlation that investment in these technologies, the heavier you invest, the greater chance you're going to get return, and pretty much everyone that's investing is achieving some level of return. So very positive, and I think what we're hoping to show you today is how these technologies can be leveraged across many disparate use cases. We'll certainly share some examples when Dave comes up around some of these themes, but they're pretty broad. Predictive maintenance these are actually the top 6 use cases, 6 of the top 7, I should say. Predictive maintenance, 75%, it was the #1 use case that they were going after. Everyone had this problem. And then you get into quality, safety, optimization, both in terms of energy consumption. If you're on the manufacturing side, how do I build product at a lower energy consumption price point? Or if you're an energy producer, how do I better forecast and optimize what I'm putting out on the grid and responding to dynamic load conditions across the industry? Then supply chain, and then aftermarket service, heavy in the automotive, ag tech space. We see a lot of those sort of emerging aftermarket services. But I'm hopeful that we can show, one, some experiences and maybe how the journey that we have helped customers with have enabled them to kind of remove some of those roadblocks that we talked about just a minute ago, and how some of the technology and our partners can help accelerate this journey so that you're in that twice as likely to get benefit through more strategic investment of AIoT technology. So with that, I'm going to turn it over to Dave, and we'll just sort of round robin here on a few different topics so that you don't have to listen to me the whole time.
Thanks, Brian. Okay.
Well, hello everyone.
Oh, are you picking me up yet? Okay, you got me. There we go. I hear me. Okay. So I'll start over. I'm Dave Froning. I'm the Director of Product Management for the industrial sector. So I've got a team of product managers that focus on things from predictive maintenance, quality, planning, forecasting, performance management, a lot of different areas relevant to industrials, but also things that are influenced by IoT. So a lot of our solutions have IoT as an input, and then we augment that with other data to drive value. My background before SAS was with General Motors. I was the business process owner for their warranty and quality systems in North America. Actually, back when Josh was a customer, he had a great pre-sales guy who came and told him how awesome SAS was and convinced him that SAS warranty analysis was a great idea. Yeah, I've been focused in the industrials for many years here at SAS, and I think the coolest thing about this is, we can talk about great technology, and you're going to hear some really cool innovations from Brian and Saurabh in a few minutes. But I wanted to start with actual proof, customer stories, things that have actually worked. So not just talking about what we want to do with IoT and AI, but what has been done, what value has been already been proven that you can build on as you move forward. So in this section, we broke it down into these areas. I'll start with industry use cases and streaming AI. Then I'll hand it back over to Brian to talk about digital twins and worker safety. And then Saurabh's going to wrap up with a deep dive into agentic AI. So lots of cool technology, but we're going to start here with those use cases. So I'm going to go into a few use cases in more detail, but I wanted to start with just a broad overview because when we talk about IoT, there are so many different use cases out there. So starting in the upper left there, Georgia Pacific, that's a manufacturing example where they're looking at predictive maintenance, quality, reliability. They were able to improve their overall equipment effectiveness by 10%. That's huge. That's better quality, that's better throughput, that's better cost, all of the above. It's the overall effectiveness of that equipment in a manufacturing facility. Volvo Truck, able to diagnose what's wrong with the truck before it gets to the dealership. So reducing the diagnostic time by 75%, so that when the truck pulls in, the technician already knows what the likely issues are, what the likely causes are, and they can get to work very quickly. Lockheed Martin, the statistic up there is 3 gigabytes per flight hour. That's how much data they're collecting off of a C-130 as it's in flight. The cool thing about that is not just that it's a huge amount of data, but they've been able to leverage those data to save hundreds of hours of flight time, reduce data cleanup by 95%, so that they've got the right data to make the right decisions and get the plane back up in the air very quickly. Wienerberger is a building supply manufacturer. For them, cost, or energy cost specifically, was a huge issue. With all the instability between Ukraine, Iran, et cetera, energy is a big cost for manufacturing, especially in their part of the manufacturing business. So driving energy costs down. So instead of optimizing for some other variables like yield or throughput, they wanted to optimize for cost, still while maintaining their quality levels and cost levels, but really drive that cost of energy down. And they saw a 15% improvement there. At First Solar, they were able to look for defects in solar panels and in less than a second be able to determine if a solar panel was good or bad. So very quickly being able to make those decisions. One of our agricultural equipment manufacturers saved over $100 million in warranty cost. So being able to look for odd behavior, fraud, waste, and abuse, be able to look for early warning of product defects so that they can put fixes in place so that they can minimize the size of recalls, warranty costs, et cetera. So huge savings there. Rijkswaterstaat is a municipality in the Netherlands. So as a lot of places in the Netherlands, they're dealing with water and water movement. And so what they have is 15,000 sensors across their infrastructure so they can monitor conditions and open and close the system as needed, monitoring it for safety, for flooding, et cetera. And then the last one is one of our port logistics customers. What they're doing, in 2026, you don't think piracy is a common thing, but it is actually a big thing if you're in the maritime business. And what they're doing is they're able to use IoT data from the ships as they're in motion, so they can look at when they left a port, when they're due at the next port, where they are at any given moment. Are they off course for where they should be? Are there delays that are unexplained? They can look at all of that information in real time to understand if there's any odd behavior. And then those anomalies, they can communicate with the ships and hopefully thwart any bad behavior that's going on. So that's kind of a high-level sweep over a lot of different industries. And the point there really is that IoT crosses borders. I mean, it's all over whatever industry you're in. But I just wanted to deep dive into a few of these. So first up, Georgia Pacific. So they are a manufacturer of paper products, wallboard, lots of things that are probably in your pantry and your bathrooms. But it's a huge volume producer. They've got over 150 sites where they need to monitor the equipment, very large equipment generating huge volumes of product at very high speeds. And in this case, they took advantage of the petabytes of historian data that they were already collecting from that equipment, married it together with a lot of open source work that they had already been doing. But to Brian's point earlier, you can build really cool models, but putting them into production and production at scale is where it gets really difficult. So it's easy to build the model, but how do you monitor it? How do you govern it? How do you maintain it over time? And in their case, they've got 20,000 unique models in place across these facilities, across the equipment. So there's a huge number of analytic models running, all of that governed by SaaS and the solutions that they've put in place. The benefit there is 30% reduction in unplanned downtime. So of course, any time that the equipment is down, you're losing production, so that's a critical metric for them. And then that 10% improvement in OEE that I mentioned earlier. So, and they've also mentioned, we've got it listed as a 9-figure benefit there. There are multiple millions that they've saved in this implementation. The next one up, so going from stationary assets to mobile assets. In Volvo's case, they've got 500,000 trucks driving around that are constantly collecting data. They're using that IoT data to diagnose what's wrong with the vehicle so that when it gets to the dealership, they know before the technician has to take a look at it. They're reducing their diagnostic time by 70%, reducing repair time by 25%, so getting the trucks back out on the road more quickly. And the interesting thing to me about this case study is how it grew over time. They started quite a few years ago when the technology infrastructure isn't where it is today. So they were taking snapshots of data. So a truck has a fault code, a check engine light, something like that. And they were bringing back a window of data, 30 seconds before, a minute after, just a subset of data. Over time, as the technology improved, they started bringing back more of the data to the point where they're bringing back data in real time now for the whole fleet. So not only are they looking at predictive maintenance on an individual truck, they can now do fleet level analysis. So they can use this data to augment things, voice of customer data like warranty and other data that is across the whole fleet, and start to look for what are the common things that are happening on trucks, and what are things that are happening on trucks that were built in a certain time period. And now they can not only do predictive maintenance, but they can do quality improvements, feed that back into the manufacturing and engineering processes to improve the products over time. SSAB, this is a Swedish steel manufacturer. I don't know if you've ever been in a steel plant, and I'm not sure who put that picture in there, but that's not what a steel plant looks like. So in a steel plant, you've got a lot of movement. You've got a lot of high-speed activity going on, a lot of very dangerous activity going on. You've got molten metal going down the conveyor system, 600 degrees, that at any moment, if that contacts water, you'll get an explosion. You've got the finish line that's going at probably up to 100 miles an hour or more of finished steel going through that process. So there's a lot of equipment, and the margin for error is very small. So if there's any sort of stoppage on that line, you end up with cobble, which is basically a buildup very quickly because something stops and everything else doesn't. It's like a traffic jam, but a lot worse. And it can be catastrophic in a plant. So failures were very important to them. They wanted to have this system in place to identify those problems, to stop them before they happen. And in their case, they were able to reduce their unplanned and unwanted events by 80%. So that's a huge impact to their process. That means they've got the systems running. They don't have these catastrophic failures. So that's an impact on quality, throughput, safety, all of the above. Huge benefits for SSAB. Wienerberger, I mentioned, this is the energy cost. The main thing they were doing here is looking at what are all the inputs into the manufacturing process? Where can I take waste out of that process? How can I be more efficient in my energy consumption? And they were able to tune the plant because now they had data from all the systems across the plant. And they were able to tune the plant. Instead of taking months to do that, they could do it in days. So they could push efficiency improvements throughout their facilities very quickly for things like quality, throughput, moisture in the product, things like that that are key factors for what they're producing. Istanbul Metropolitan Municipality. So Istanbul has the honor of being named the most, TomTom Traffic Index as the most congested city in the world. So if you were hoping your city was the most congested in the world, you lost because Istanbul won. What they were able to do here is they did have sensors all over the city. So traffic sensors, understanding road capacities, lots of information that they were gathering, but they weren't taking advantage of. So by putting AI combined with their IoT data they were already collecting, they were able to do some new services. So not just improve efficiency, but put new services in place, park and ride services that were driven by a mobile app, so people could more efficiently get where they needed to go, optimizing bus schedules, lots of things that were going into looking at how can I take the data that I already have, things I'm already collecting, and take advantage of them. So that was the last of those examples, and I'll leave this up for a minute if you want to take a look at it. These are a few presentations coming up in the next couple of days that are relevant to this area. So these are some customer examples. There's a Lockheed Martin, Volvo, Dow, KMS, and Lenovo panel, or not a panel, probably a Q&A. Executive Insights, that's coming up tomorrow. And there are several other customer and SaaS presentations that are relevant to this area. So I wanted to just go through those examples. Hopefully you saw something in there, whether it was in your industry or another industry, that is an example of how you could take advantage of the investments that you've already made. We already have a lot of data, and it usually exists in silos across many different parts of the organization. How can you bring that together and take advantage of it? With that, I'm going to move ahead to the next section, which is also me, talking about streaming AI. So, if you think about the problem-solving process, starting from data being generated and acquired, analyzed, finding those insights, finding those needles in the haystack, those interesting tidbits, and then making a decision. So whether you're detecting anomalies that are going to help you produce a better quality product, whether you're doing predictive maintenance, whether you're doing traffic management, that basic idea is the same. And the goal is, how can I shorten that? How can I get to the decision faster? And there's a lot of ways that you can do that. One is just analytics and AI in general. You know, it's a much more efficient way of finding those needles in the haystack. But doing that on an ad hoc basis still isn't very efficient. So we put in automation. How can I automatically find those things, run the analytics on a regular basis? What we're talking about today is streaming analytics. How can I move those analytics closer to the data so that I don't have to move the data back to the cloud or somewhere else to analyze it if I don't need to? I don't have to store those data if I don't need to. How can I shorten that time of analytics, automation, and streaming? And that's really where SaaS event stream processing comes in. So it addresses those issues, because not only do you need to have the analytics as close to the data as possible, you also need to have those models managed, and ESP does that as well. These are just a few key aspects of the software. It is agile. It can run from anywhere from the cloud. So if you don't have need for edge compute, you don't need it. But if you wanted to move that down to a gateway or to a sensor, or even on a camera on the shop floor, you can run it at the edge. And if you're doing that, then you don't need to bring back any data. You don't need to move any data or store it. But they also, not just to have the analytics there, but to have those generative AI and high-end analytics pushed out to the edge. So it's not just about simple reporting and filtering at the edge. It's how can I take the analytics and move them to the data. Being fast, so millions of events per second. Agnostic deployment, being able to deploy anywhere, lightweight, portable, with containerized projects. So there's not a lot of requirements on the infrastructure where you're deploying it. Flexible from a user's perspective. Do you like to write code? Great, you can do that. Do you not like to write code? Great, you don't have to do that. So having that no code or yes code option there. And then finally being able to look at things from an enterprise. So we're not just talking about a science project off on the side, we're talking about data from across the enterprise. Being able to look at it at scale, high volumes across the organization. And event stream processing was really a core technology in most of those use cases that I just talked about. So if you've ever seen an ESP presentation before, you probably saw a peacock chart with lots of colors and lots of analytics listed out. Well, we've gotten to the point where there were so many analytics that you can run in event stream processing that the slide was just too much to fit on one slide. So this is the evolution of that in bigger chunks. So being able to run machine learning algorithms, supervised and unsupervised, statistical analysis, traditional statistics, multimedia processing. So if you're looking at audio clips, video, photographs, any of that, analytics can be pushed into the stream as well. Being able to run applications, so things like outlier detection and digital signal processing. So not just simple analytics, but complex applications running in real time. Model packages, so being open to third parties like Onyx and other standards that allow you to pull in other types of analytics. And then last, agentic AI, which Saurabh's going to talk about. We've introduced some new technology, model context protocol, so that ESP can now run agents. You can build agents from within ESP as well. So one more customer example, because I like customer examples. This is a solar panel manufacturing example. And so what you're looking at on the upper right there is a solar panel. But if there are cracks, if there are other types of defects in the materials, they're defective, they're useless, and they can get in the way of other good panels. So they want to get rid of those as early as possible and as early in the process as possible. So what this is showing is a top-down view. So this is from an existing stationary security camera, so a low-cost camera that was already there in place, looking down on the panels as they move through. And as it's moving through that process, being able to detect from that security camera if there are defects in the panel. Now over on the right side, over here, this is a line scan camera, and that's about a $50,000 piece of equipment. That's the traditional way of doing this. So it's looking at the panel as the panel moves over, looking for those defects. But again, that's a $50,000 camera versus here looking from the top down with an existing security camera, so no hardware cost, it was already there. And being able to not just look at it at one point in time, but across that entire process. And what they found was they reduced their unplanned downtimes by half, so huge benefits because they could get those panels out more accurately, get them out of the system so they're not blocking other good panels that are coming through. Increases in yield and throughput, and those things are, of course, difficult to balance because often if you're increasing yield, you're going to slow down your throughput, but they were able to improve both. And cost avoidance. They didn't have to have that $50,000 line camera there on every line that was running these panels. So huge benefits. Being able to really use some existing data that's not very expensive to collect. Security cameras are all over your facilities. Why not use them? And Brian will be talking about some examples of worker safety and other things that you can use those same cameras for as well. Just kind of winding down here on event stream processing. Streaming analytics is really at the crossroads of technology. So it's important from our perspective to be open. So ESP is built to work with many open standards. I won't go through every logo on that chart, but as you can see, there are a lot of them that we have interoperability with because we can't just stand alone. The infrastructure is very complex that we have to deal with, existing OT and IT systems, and we've built the system to work well with all of them. And then my last slide, I mentioned this earlier, but as we get into the world of agentic AI that you'll hear more about in a few minutes, it's important from our perspective that ESP uses the Model Context Protocol standard so that we can run agents. You can build it. You can build your own agents and deploy them. But it allows you to take that streaming IoT data that you've already got and augment that with other data sources. Maybe you need to go out and check a weather system, or maybe you need to integrate with your ERP or something like that and have the agents go out and do tasks for you to integrate when something interesting is found in the IoT data. All of that is possible now with MCP capabilities in ESP. And with that, we're back. A few more examples of sessions in the next few days. So you might want to take a picture of that one as well. But these are sessions that really show some of the advantages around event stream processing and Model Context Protocol. And with that, I will hand it over to Brian. Maybe I should leave that up.
All right. So your host for the next two sections, digital twin worker safety. So I tend to talk about this as like strategic AI investments. We can talk specific technologies around predictive maintenance or quality yield improvements, but these are some of the macro level conversations that organizations are wanting to have these days, and we're seeing some investment strategies. So that's sort of why we structured it this way. Digital twin, if I asked everyone in the room to write down what is a digital twin, I bet you, I don't know how many people are in the room, but I'd probably get at least that many answers. Because it is so ubiquitous. Everyone has a different perspective of what is a digital twin. Is it a predictive model that notifies me that this bearing's about to fail? Is it an optimization model that sets up a digital version of my plant so I can lower my energy spend like Wienerberger did with their natural gas consumption? And anywhere in between. And I think sort of the cutting edge, the next wave of digital twin, a lot of people think visual technologies. I mean, that's 3D representations of physical things. And so to kind of take the step from an organization perspective, this is not something we would want to go off and build on our own. And so we partnered with Epic Games to use the Unreal Engine. This was announced last year at Innovate. And I would say the IoT division has been one of the, I'd say, first movers within the company of like finding new and creative ways working with our manufacturing utility clients to think about how this technology could drive value. And I'll share a few of those examples as we go. And so, again, we're using the Unreal Engine, which I'm assuming a lot of folks know what the Unreal Engine is. If you don't, if you have kids that play Fortnite, if you do, Unreal Engine. Are you a Star Wars fan? Mandalorian? Use the Unreal Engine for the filming and the digital representation for that show. So, very powerful photorealistic engine that's powering a lot of sort of these 3D simulation environments. And so our goal was, how do we bring the power of analytics to that 3D representation and make it a two-way conversation from kind of the physical to digital connected world. And so I'll share a few examples where we've kind of handled this along the way. The first being AGV optimization. This is probably a fairly common problem in manufacturing today. Using guided vehicles, automated fork trucks for material movement and sequencing. If you've been in the plants, you can see the ones that are really well optimized, that everything kind of flows. They've got their route lanes planned very appropriately, and then you see the others where like one will move and the other one waits, and then the other one moves, and they're constantly stopping. Well, one of the challenges is how do you optimize that directed flow and try different scenarios in sort of a virtual environment before you actually have to disrupt your manufacturing operations with a bunch of this sort of design of experiments. And so the goal here, we worked with Georgia Pacific. Again, we use Georgia Pacific a lot because they force our hand. They're constantly bringing their latest and greatest challenges and say, help us solve these. And this was one of those. And it was, they had certain requirements of a 2-second separation on the various traffic lanes, both directed and undirected lanes. And so we came in with our gaming team and modeled their environment to look at their conveyors, material movement, robotic systems, packaging, palletizers, and said, okay, we can sort of create this environment and sort of simulate movement, but we were able to pull the geospatial data out of the three-dimensional world and then do traditional sort of 2D flow system dynamic modeling to better predict and traffic, throughput, volume, dwell time of the AGVs, et cetera. And so where do you put those key points within the manufacturing floor? So again, a way that we were using this new technology to solve what traditionally would have been a bit of a trial and error and sort of a one-dimensional approach. You sort of design it, you see if it works, and you react and change. So that's one example. The other, you'll hear there's several sessions, and Bobby here with, I was going to say the bald guy, but then I looked, and I mean, I'm sorry. There's like a, did y'all get an invite to table one? What's going on here? I'm teasing. These are my buddies. I only pick on you if I like you. That's sort of the rule. But worker safety. So this is an application that we are working with our ecosystem partners. We mentioned KMS and Lenovo earlier. Very instrumental in us bringing this to market. And the idea is around worker safety, and I'll talk about that more in a moment, but why this is interesting, building models today, whether they be using camera data or sensor data, can be expensive. It's costly to acquire all of the real-world data you need to build more accurate models. Maybe it's newly instrumented systems. It takes you a while to collect, transmit, store, and analyze all that data. In the case of cameras, different lighting conditions, different ethnicities of workers, different color vests, different color hard hats, different heights of employees. And I'll take the short joke since I made the bald joke. I'm the short guy in that list. But it may be around PPE compliance and other interactions with energized assets. To capture all that data using real cameras can be super expensive to get all the corner cases evaluated. And so we had a hypothesis working with some of our R&D partners and our AIM team. They have a booth in the Innovation Hub as well, so please stop by and talk to them. Very smart folks around vision-based applications. And the hypothesis was that we could simulate image data and build good CV models. Our vice president, that's our boss, pretty much, I won't use his exact words, but no, that won't happen. I don't trust it. I don't believe it. That can't be done. And so we tried it, and we were pretty successful. So here's an example, again, sort of warehousing within our own environment. Different folks like bending over, leaning over, conveyors, different context of folks. They're going to be wearing different PPE. Pretty soon someone's doing a jumping jack, so maybe it was a morning exercise briefing here. But creating all of these various synthetic configurations, we were able to have image data. And again, this is a bit of more of a cartoon representation of it, but you can see various configuration, and we tested this in our lab, and this is sort of the realities of it. We have a warehouse on campus, and we simulated that in a three-dimensional world, very low tech, because it was just a science project to start. And then we use that to generate synthetic images, train the models against that, ran real data through it, and we're getting over 80% accuracy in a real environment. Now, it's pretty similar. So how does it translate? So then we took it to other environments, and it translated pretty well, not at the 80% level, but what that was is a step change in terms of performance to get new models developed and out the door quickly. And then you can go handle those corner cases, fringe cases by exception, but it definitely gives you a much richer and much more robust starting point. So pretty interesting way in which this technology has added value. The third, very similar. We were actually showing this to some customers, and they said, well, I don't have manufacturing plants. I inspect and maintain utility lines. So how can you help me do that for equipment inspections? So here's some examples of just dynamic configurations, different pole configurations, different weather conditions, looking at potentially arcing or various configurations. All of that data can then be fed in to create these models very, very rapidly. Again, just a way in this way technology is step changing and accelerating performance in areas that traditionally people wouldn't even tackle these types of problems without huge budgets. I talked to legacy and implementation cost. They realized to invest to go gather all the real world data needed to even prove that this was doable. I mean, even hypothesis testing, this can be a great step change accelerator. And we're pretty excited about that. There's another one that I can't talk about today, but I encourage you to show up to the main stage keynote tomorrow, and you'll get to hear about another digital twin example that we were a part of. So with that, if you'd like to learn more, again, go to the opening session, listen to Brian Harris tomorrow. Brian has been one of the biggest sponsors and advocates of this investment, this sort of digital twin gaming division within our company. Stop by the booth. We have the worker safety application up and running. We can talk a little bit. The AIM team is there. They can talk about how they built the models. And then a couple examples where we're showing some of the digital twins in action. Then Steve's got a super demo that will kind of show you how you do this at scale. It's really pretty interesting. So the next one is worker safety. So this started, Bobby, correct me if I'm wrong. I remember some of our first conversations were around the COVID time when organizations were really struggling with social distancing and folks getting them in the plant and keeping them safe, and then it sort of evolved from there. I mean, it certainly got more complex. And again, I think there's nothing cooler than quoting yourself on a presentation, so I did that. I don't know if that's been done, but again, as I look at this and the kind of the way I view the world, I think in protecting your employee safety, it's a very complex industrial environments that you all come from. It's about more than just compliance and just reporting and sort of after the fact. You need continuous proactive risk identification and a commitment to prevention. Not just a commitment to training, but a commitment to prevent these issues. And there's some uncomfortable conversations with that last little statement, commitment to prevention, because once you put things in place to detect that a person may be doing something you wish they wouldn't do, now you know. Well, once you know, there's an obligation or to maybe take action, and that's that proactive risk component. So again, best practice for you all, future, quote yourself, they're the best quotes. So why are these challenges? Why has worker safety become so important? One, labor shortages. I mean, you see it every day. We have more open jobs in manufacturing and the industrial world than we have bodies to fill them. And it's not that people are staying in those roles for 30 years. Like my dad and my grandparents, and they all, I think between the three of them, 127 years at Norfolk Southern. I had 2 as a co-op, so I was the outlier in the family. But there was, traditionally, you'd get in and you'd stay. That doesn't happen now. There's a lot more turnover. The training programs. If you've ever been to a plant, and no disrespect to any of your quality departments that run these plants and these trainings, they're typically pretty high level. I don't think they're very contextual to the role of the person. They're not personalized to me and the job that you're asking me to do. And so I think there are sometimes some blind spots, and you're putting folks into an organization that they're finding themselves doing something wrong 99 times, and the 100th time they'll get caught. And it's, again, just because they didn't know better, or maybe they thought they could get away with it, or that's the way they were told, or maybe they weren't told at all. All a problem. And then we would argue that there's insufficient monitoring, because visibility opens up a whole nother can of conversation. So what we would consider the current environment. There are complex work processes. Things are changing so rapidly because of this demand for productivity. You have to be more agile. You're changing things up. The process that you did yesterday may not be the same as the process you want today. And that creates risk. And you've got all sorts of regulatory requirements, reporting, legal, safety, et cetera, that if you don't keep a watchful eye on this, you're going to get buried. So again, there's strict guidelines here in place to kind of keep you marching in the right direction. So what we're hearing is that organizations do want that risk mitigation. They do want to improve visibility. They do want to maintain compliance. They recognize that their employees are their most critical resource. And they do want technology in place to improve their responsiveness. They want to get out in front of these issues so that organizations and their workers are better protected. So all that being said, you have a market conditions, you have business objectives that align. We started making the investments to create this workplace safety application. And again, this is using cameras and other sensor-based data feeds to monitor and create a proactive security perimeter around employees and their behaviors. You can use pre-built models that we ship or custom models. And then we have an expanding ecosystem of partners to deliver this full solution. Dave mentioned earlier when he showed the ecosystem slide just around streaming, whether it be for modeling or DevOps or compute hardware, cloud providers. This is no different. We are one piece of a broader value chain, and it takes an ecosystem to unlock this value. Now, as you drill into that, we mentioned KMS and Lenovo. They have a session tomorrow in the executive manufacturing insight section. I encourage you to go listen. So when we look at this, it's all of us working together. Lenovo driving hardware, edge implementation, compute services. KMS delivering some of the implementation, configuration, customization services. We have a UI that sort of orchestrates the business process, and then we think our analytics, our models, the capabilities that we offer, you bring all that together, you can unlock these really purpose-built, value-based applications for industry. So this is it in action. And the reason I bring this up is because I had a question the other day. Actually, I was talking to an analyst, and they said, why don't you just put these models on the camera? And I'm like, well, because there's several nuances here. Just take PPE. Well, am I compliant with safety glasses if they're on top of my head? Am I compliant if they're in my front pocket? Well, if I just have a model that says you're wearing safety glasses, I might detect that you're compliant, but you don't have them in the right location. So there's like some open pose, body position, you know, to down select to a region or frame. There's how do you provision new cameras? How do you deploy new models? How do you define zones, prohibitive spaces with geofences? There's a whole orchestration here that it's more than just a camera. And then prohibitive space. You see that little blue box around the little rolly cart on the floor there. Well, say that's a running machine. Well, if the machine's running, it's probably a prohibitive space. If the machine's not running, it's probably not prohibited because I can go there to do my maintenance or repair work. So everything's about context. They may seem simple on the surface. There's a lot of complexity and a lot of orchestration that goes to bring all of these pieces together. So again, this application gives you that full spectrum, defining zones, defining associated hardware. So, well, what do I do if I detect an unsafe incident? Do I just send an email? Do I have a light post that starts blinking red? Do you want to initiate audible alarms? You can sequence all of that sort of orchestration within this app. And again, that's not just SaaS. That's us and our ecosystem. And that partner is so critical to what we do. And I know we have several partners in the room for other use cases, other applications that we're trying to go after. But this is a model that we think is very key and replicates. We've had several successes. I won't spend a lot of time here because I don't want to steal all of Saurabh's time. But again, across various industries, various experiences, we'd love to talk more about this. Please, if you want to learn more, come by the Innovation Hub. We actually are demoing the worker safety solution. We have KMS and Lenovo talking twice, number 2 and number 4. They're doing a kickoff for the executive insight session, and then they have a specific solution theater session. And then we also have a worker or a super demo where we'll go a bit deeper into that application, some of the nuts and bolts of how this all comes together. But pretty exciting. Again, it's worker safety, but widen your field of vision a little bit and think about how this, what kind of new creative problem do you think we can solve together. With that, the latest and greatest stuff, which is Saurabh gets all the cool topics.
Thank you, Brian. I'm going to be speaking from the podium, so can you guys hear me all right? Okay. I was sitting here watching all the slides, and looks like Brian got all the cool slides.
That's because Brian created all the slides.
Next year, we got to flip the script. My name is Saurabh Mishra. I am part of the Industrials and IoT division at SAS. I lead product strategy. So I'm going to be talking about agentic AI. And throughout the next 2 days, you're going to be hearing agentic AI about 15,000 times. So I'm going to be taking the first 100 of those today. So before I get started, I'm going to kind of break this down into a few different sections. I want to talk about some motivation, some drivers for why we are thinking strongly about it, some examples, why agents make sense and where they make sense, and then I'm going to finish it off with an example of an application that we launched recently. We alluded to it in the section that Brian and Dave talked about. It's a SAS Retrieval Agent Manager, or RAM. So before I get started, actually when Brian was talking about the worker safety, he made a statement, everything is about context. And that is fundamental. That is fundamental to the world of AI. That's fundamental to agentic AI. So let me start with that. When I think about context, I think about unstructured data. And as this slide talks about, there is a context gap. And that context gap can be fulfilled if you tap into your unstructured data. And there's some numbers here on the slide that just talk about how much of the enterprise data is really unstructured. It's overwhelming. It's over 80% of the enterprise data is unstructured, and it's growing at a much faster rate than your structured data. And what is this unstructured data? These are your documents. These are your files, your PDFs, your Office documents, your notes, your scanned documents. So it's really important to tap into this. And this is what brings context to agents. And the way you do this is through a concept called RAG, or Retrieval Augmented Generation. Now, this is going to be the first of few three-letter acronyms that I'm going to be talking about. So RAG is actually quite popular. And for those who haven't heard of RAG, it's a really simple concept, but really powerful. So the idea behind RAG is, think about a large language model. You guys probably all interface with ChatGPT or Claude, whatever your favorite model is. You ask a question, it gives a response. Now, it gives a response based on the data that it was trained on, which, as I like to call, is the internet data. And it's a good thing that it does not know about your private domain data. Well, but that's a problem if you're asking a question about your data, right? So RAG helps you handle that problem. So RAG essentially makes it a two-step workflow. So the first step is search. So when you ask a question, the first thing it'll do is it'll actually go and search for that keyword, that query inside your knowledge base. It'll get some information back, and then the next step is it'll send that information to the large language model using only the generative power of that model, but locking the context. It's saying that, give me a response, but don't use your internet-trained knowledge. Use my data, but give me a response. Use the generative powers, but lock it down to this context. So RAG essentially is about LLM plus enterprise knowledge base coming together. Why does RAG matter? As you can imagine, factuality and trust. You're able to cite the sources. So when you get a response, you don't just get a response. You're able to unpack the response, see where it came from, what documents were consulted. It's fresh because your data is not static, right? I mean, even though we're talking about large corpus of data, as we saw on previous slide, it's growing fast. So your data can change, and RAG allows you to bring most recent data. So you can actually keep the pipeline fresh. Your data is your data, so you can govern it. Governance is important. And last but not the least, flexibility. RAG is not tied to any specific large language model. This is an architecture pattern. If you decide to change the large language model, that's totally fine. So tomorrow, if a better, cheaper model becomes available, you can totally switch it. So that's RAG for you. Now, the next concept is going to be around outcomes. So what RAG is helping us do is helping us answer questions, but we need to move from answers to outcomes, and that's where agentic AI comes in. So as you can see, there's obviously several projections around this. The numbers are probably less important, but directionally, this is a significant movement. But if you just look at some of these numbers, by 2028, almost 1/3 of enterprise software applications will have some flavor of agentic AI, which is up from 1% in 2024. I mean, that's just a humongous increase. So let's talk about this. So we think about agents as the second enterprise game changer after RAG. And agents actually go a step further, right? So now we're talking about the ability to reason and act. So you're not just asking a question and getting a response. You're able to give the agent a goal, and the agent is able to reason it, come up with a plan, and then actually go ahead and orchestrate that plan. And when you think about agents, something becomes really important, and we'll talk about this more. It's tools. So Dave talked about the concept of MCP. That's the other three-letter acronym. So MCP is Model Context Protocol, and I'm going to talking about that a little bit later. But agents need access to tools so that they can actually automate some of the tasks that you're asking the agents to perform. Now, why agents matter? Well, obviously, agents are able to help with automation, so the autonomy aspect is really important. Agents can be personalized. They are acting upon your data. They are able to pull context using RAG, so they can actually tailor their behavior based on changes. The same concept allows them to adapt as enterprise environment changes. If new data comes in, agents are able to adapt, so they are not the static performer. And again, the agents require governance, so all the building blocks, the documentation, the tools are your building blocks. So you can actually put guardrails around it. You can say who can access these, who cannot access this, what can they perform, what cannot they perform. So there's governance involved here. So to kind of summarize this, I want to think about agents in two ways. How do they get their grounding, their knowledge, and how do they act? And the first aspect is enabled by RAG, and the second is through MCP. So let's just take a look at this in one more level of detail. So I already talked about the concept of RAG. RAG allows the ability to ground LLM answers. But the pipeline to build RAG is non-trivial. So you need to take your knowledge base and you need to convert it into a format called vector embeddings, and they get saved into a special database called vector database. Once you've done that, this is what enables the search part of it. So if you remember that you ask a question and you first search, get a response. So you need to be able to do this almost like prerequisite before you can enable search. So that is how RAG is enabled. So user asks a question. If you look at the bottom left diagram, user asks a question. The search happens against the vector database. You get the context back. This is what you send to the LLM, and you get a response. Model Context Protocol is actually, the standard has become a de facto standard. It was launched by Anthropic, and now it's been adopted by all the major providers. And the concept of Model Context Protocol is also really simple. There's three aspects to it. One is the concept of a catalog. So think about a list of tools and descriptions, right? So anything that you want to expose as tools, think of a catalog, a dictionary, where there's a tool name and there's a description attached to it. And this is the catalog that a language model will reference when it's trying to decide what is the right tool to use. So this description is really important. But that's just one aspect of it. Then there is the protocol aspect of it, which makes it standard. And the third is the execution. So think about what are you trying to create tools against. So you're trying to create tools on potentially structured data, your Oracle and Postgres databases, APIs that already exist in your organization. This is how you've conducted business maybe in the past. These are APIs that are called by your existing workflows. So you can actually put an MCP layer on all of that. And this is a really fundamental shift, because once you do that, the agents are now able to access all aspects of your organizational capabilities with governance in force. So that's why Model Context Protocol is such an important part of agents. And like I said, we launched a product late last year. We call it SaaS Retrieval Agent Manager, or RAM for short, another three-letter acronym for you. And our goal is to accelerate development of context-aware AI agents for domain use cases. So just some key capabilities of RAM here. So we support agentic workflows for all types of data. So we have full support for RAG, so it supports unstructured data. It has native support for MCP, which allows it to access structured data. So you can actually have agents cross between unstructured and structured data. Transparent and trustworthy AI. So every response that we generate, whether that's just an answer to a question, whether that's a recommendation by an agent to go ahead and do a particular task, is backed with citation. So you're able to open the hood anytime and unpack that response, see what went on in generating that. No code to pro code, so majority of this application is completely no code, which is a big shift because if you're trying to implement RAG on your own, if you're trying to create agents on your own, many frameworks are available, but they are all pretty code heavy, code intensive. So we've taken the job of abstracting that and created a no-code workflow across all of it. There's pockets in this application where you are able to inject special custom logic by code, so you can use Python and inject logic in it, but you can go from A to Z without using any code. We support bring your own GenAI and deploy your way. So we are agnostic to the underlying dependencies, be it the language model, be it the vector database, be it things like embedding models. So if you have, as an organization, a relationship with a model provider or a vector database in-house, then that's something that you can connect to it. We also offer a lot of flexibility from a deployment perspective, so we can deploy in cloud, Azure, AWS. We are seeing a lot of traction in on-prem deployments in regulated industries. We actually have some work going on with both Intel and Red Hat to create more optimized CPU-efficient deployments of RAM. And centralized governance. So everything in RAM has a centralized governance layer, whether that's managing your documentation to managing your agents. So with that, I'm going to actually talk about some examples of an agent. And I'm going to use this, and I'm going to actually stop this video in a few places to highlight some aspects of this agent. So let me make sure it's running. So as you can probably see, this is an agent that helps me with knee surgery authorization. And you might wonder why I chose a knee surgery authorization for an industrial session. Well, I don't know about you, but after walking 2 days back and forth between all of these conference rooms and my hotel rooms, I might need this agent to help me. But jokes apart, this is really a simple agent. The idea was to highlight, sometimes we tend to mystify things. An agent seems like just this mysterious thing. So I wanted to give an example of what an agent can do, and then we'll talk about how this agent was constructed. So this is the user interface of RAM, where you are actually chatting with an agent, but you don't have to be in RAM to use an agent. Everything that we have has an API layer, so you can actually connect to your systems. But one of the first things I'm going to ask this agent, or I had asked this agent, was, I don't know if you can read this. I cannot read this here also. But I asked the agent, what tools and documents do you have access to? So I wanted to just understand what are the capabilities of this agent. And like I said, we built agents on top of the RAG layer and the MCP layer. So one of the first things the agent did was that, look, I have access to these data sources. So you can see on the top, it's listing some data sources. And I have access to these tools. So in fact, it's saying that I can read patient databases. I can actually search and document. So those are the tools that it has access to. So now I understand what the agent does, what's the scope of this agent. So I begin to ask more questions. So the next question I asked, what are the patients who are currently queued up, right? So this is a pre-authorization agent. So it is actually going to be helping me understand which patient is pre-authorized for a knee surgery and which patient is not. So I asked, OK, give me a list of patients who are actually in my queue. So this information would typically live in a database, right? So in this case, we have an MCP tool against a Postgres database, and it actually pulled up that patient table and gave me a list of those, right? So this is an agent understanding the question and making a call to a Postgres database as a tool. So now I have the list of patients. the next thing I did was that, okay, so now I understand, so like I said, at any point, I can actually open the hood and understand where this response came from. So in RAM, if you see a response, let me actually go back, you're able to, this area, come back. So that if you click on that, it'll actually open up what we call an observability pane. And an observability pane allows you to understand what's going on in generating this response. So in this case, as you can see, it called a Postgres tool, it generated SQL, and this is the SQL that's running to generate that list of patients. So now I have my list of patients that came back. The next thing I asked about for this agent was that, okay, I have the list of patients. You also have the policy documents, right? So insurance companies and hospital providers actually have this documented. This is where your unstructured data context comes in. Show me some guidelines about knee surgery pre-authorization. So it showed me a list of notes that providers and insurance companies use to make this decision. And then you can actually then start to go into, okay, help me answer a particular case. So I actually gave it a patient name. And help me, this patient, Alicia, help assess this person's eligibility for a knee surgery authorization. So now it puts everything together. It looks at Alicia's record that it has in the patient database. It looks at the policy documentation. It does a cross-check and comes back and says that based on these conditions, here is my recommendation, whether you should go for it or not, right? So that's the power of the agent. It is able to kind of reason from documents, look at your structured data, and make a determination. And as you can imagine, I mean, this can be as automated or as less automated as you want. It can stop at making a recommendation, or if you want to go ahead and make an appointment or make an entry in another system, generate an email, it can do all of that. So that is an example of interacting with an agent. So now, how do we develop agents inside SaaS RAM? So the first thing that the agents have to do is to interpret the user intent. They have to decide what are the underlying components they need to call. That may involve RAG, tools, or both. And then depending on which direction it has to go, it will make those calls and come back and give you a context-aware response. In terms of development, I talked about that agents can be no code. So we have this entire pipeline managed through just point and click, drag and drop. But there is scope for you to introduce custom code. So you can actually guide the custom agent logic on your own. So if there are data scientists who are like, I need to be very specific about what this agent does, we actually have place in RAM where you can actually drop Python code, and that becomes the orchestration. Just to kind of pull it all together, so agent development is kind of hinged upon these two pillars of RAG and MCP. On the top left, you see the RAG pipeline, where you start with enterprise documents. You go through the process of converting these documents into vector embeddings, as I talked about. Now, unfortunately, when you do this, there are many, many settings, many configurations involved, and it's hard to know what is the most optimal, the gold standard. So you may have to do some trial and error. And to actually to help you make the right decision, we have a concept of evaluating these pipelines. So we help you evaluate to choose the best settings. So that gets you ready for RAG. And then on the bottom left, we have a space where you can actually build your tools. So you can actually build MCP tools from ground up. Or if there is a container that's out there, you can drop that container inside RAM, and that instantiates and creates automatically. Once these two are available to you, then you get into the agent development lifecycle. Now, agent development itself can be an experimental exercise because you are making some decisions. You're choosing a language model. You're choosing some tools. You're choosing a reasoning option. You may not know exactly what's the right fit. So within RAM, we have user interface that allows you to experiment, create multiple iterations of it, and have some test cases. So you could actually have a subject matter expert that could write some test cases, and that becomes the basis for evaluating and then picking out the best experiment as the champion one. So that's how agent development happens in RAM. So this is an example video of the same agent And here, I'm going to walk through showing how this agent was developed. So I'm going to just, again, step through a few different paths here. So in this case, I'm in our agents tab. As you can see, we have many tabs on the left. I'm in the agent tab, and I'm talking about this knee surgery authorization agent. You see, we are in the summary tab, where we just provide a name and a description of this agent. And on the bottom side, you see experiments. So as you can see that you may actually decide to create multiple variations of this agent before you pick a champion one. So I don't know if you can read it or not. The first one is a challenger, and the bottom experiment is labeled as champion. So I did my experimentation, and then I chose that bottom one as my champion one. But to get here, I also needed to do a few things. So for each experiment, you need to choose your LLMs, you need to choose your tools, you need to choose your documents. So we have UI, which allows you to do that. So as you can see, you can choose tools, you can choose your documents, just stepping through the UI. And this is an area where you actually define your RAG pipelines. So RAG pipelines are document dependent. So I'm jumping over to the other section in the application where you actually bring documents in. And this could be from multiple sources. And you go through the process of creating RAG pipelines. RAG pipelines also require some level of experimentation. So we have the same champion challenger model here too. And the last area is where we develop MCP tools. So we have a couple of different ways of creating MCP tools, but all of it is managed through the same user interface. So you do that, you launch these MCP tools. So in this case, we have a Postgres tool that is launched to connect to the patient database. And that all comes together in the agent interface to construct this agent. So that was a quick walkthrough of creating an agent inside RAM. But the story gets more interesting from here. Why stick with one agent? Why not have multiple agents? So we now have a concept of multi-agent orchestration in RAM. And this is based on another three-letter acronym A2A, or agent-to-agent protocol that was launched by Google, which is now the common standard. So in RAM, we support agent-to-agent. It is a pretty recent development. And you can imagine, agents are in some ways like people. So you may have specialist agents, and then you may have a supervisor agent that is actually delegating and orchestrating that task between them. A2A essentially is a mirror of that. So you're going to create these delegate agents that are specialized. This allows parallel execution. It allows higher quality. You can actually test those specialist agents really well, and then enable the orchestration. So the idea here is that you will have a supervisor agent, which is the orchestrator. The orchestrator agent is the one that has the task of doing the reasoning, to come up with the plan. What are we going to do? The supervisor agent on its own does not have access to tools. So it is not actually going to make any tool calls directly, because its job is to come up with the plan and then delegate to the non-supervisor agent, the specialist ones, which actually handle the execution of the task. Now, the way the orchestrator agents work, there's a couple of different patterns around it. There's one called React, which is the supervisor agent will basically just start the process and iteratively improve and converge. There is another one, which is Tura-based planning, where you actually first take some time and create a plan, and then go ahead and execute that. So that's all happening in the supervisor agent. The non-supervisor agent, or the specialist ones, are just standard agents, just like what I showed you. You can actually use these agents on its own, but they can actually be orchestrated through a supervisor agent as well. So as you can imagine, there is a lot going on. This process can get complex. And at every step of the way, it's really important to know that I can actually open the hood and see what happened, right? So we allow you access to full trace for sequence of steps that were orchestrated. So we not only show you on the UI, you can see what happened, what tools were called, what documents were consulted. With every step, we show you latency and cost implications, so that you know that this operation is going to take time, this operation might be costly. And we also allow you to export this trace. So if you have your preferred tool, there's a number of tools like ClickHouse, Arise, where you can actually analyze trace data, then you can actually do that as well. To bring it all together, this is how an agentic pipeline orchestration works inside RAM. So the top layer is the orchestration layer. So that could be powered by a single agent or multiple agents. This is where we support that deep observability that I just talked about. We actually are able to run these agents in separate containers. So there is workload isolation happening here. If you look at the bottom layer, the center part of it is the reasoning. Reasoning is almost always powered by a large language model or a smaller language model. We're actually doing some work with Intel right now where we are experimenting with smaller language models. This is where you have the tool calls happening. So you need to understand the token cost and latency. And then we have already talked about the RAG layer and the MCP execution layer. So just a quick roundup of key benefits. So I talked about time to value, so no code, intuitive UI, fit for purpose. So you can start with chat. You have access to APIs. You can go to full agent implementation, very flexible architecture, and answers you can trust. We put a lot of emphasis on traceability and governance. A use case that you will be seeing, and Brian alluded to this, is a use case around accelerating the time from detection to correction. So as you can imagine, I'm kind of bringing it back to the industrial sector. Alert response management is a real challenge. As condition-based monitoring systems have improved, they're actually doing a great job of monitoring these complex systems, but the output is alerts. And often these alerts lack the context for the technicians to actually go and diagnose. So to be able to use an agentic AI-based solution to close that gap is really, really important. And we're going to be highlighting that in the IoT booth with a real example. So in this case, what's happening, and I'm going to just run through this real quick so that we have some time for Q&A. On the top left, we have ESP, our event stream processing application that's monitoring real sensor feeds. That's the one that's doing the monitoring, detecting alerts. On the bottom left is all of the agent part powered by RAG and MCP. And then we connect the dots to offer a pretty holistic decision support system. This is the schematic of the device or the appliance that we have in the booth. So it's a small motor that has a sensor board on it, local compute on it, really to mirror what a small industrial device might look like. And we actually run the gamut on this device. So the first step we would show you is sensor-based data coming from this device that we are monitoring with ESP. This is where we are actually detecting that something might be going on. And then in parallel, we already have the documentation that is available with this device or with an industrial device like this that's been prepared so that we are able to go and ask the right questions. So this is where the RAG layer comes in. We also have the agents and the MCP layer prepared so that once we get a scenario, once we get a situation, we're able to ask the agent the right question. And the agent is going to help us with decision support. So it'll actually step through what's going on with this device. What do I need to remediate? What parts do I need to have in stock? And whether I have the right personnel to actually carry out that maintenance. So it'll give me a guided response stepwise to make that call. And this is my last slide. So I talked about some work that we are doing with Intel. So if that's of interest to you, I'm going to be talking along with Intel. That's Wednesday morning. We also have some other sessions going on with the use of ESP as an MCP server. So that's quite interesting. That's the number 3. And I already talked about the live demo that's happening in IoT booth. So I highly recommend you check that out. I think that's a wrap for me.
You have one more. There's so many agent-based sessions. There's actually, he got 2 slides worth of content.
Well, I said 15,000 times, right? So there you go.
Yeah.
So yeah, there's a number of other ones. In fact, Lockheed is going to be talking about AI-powered maintenance. So that's tomorrow. I know we are working with Factory XT, so there is a session for that. And then I'm going to be closing out this conference Wednesday evening, the anatomy of an enterprise AI agent. That's on Wednesday at 5 p.m. So check that out. Thank you.
Sarab would really appreciate it if you guys all stay. in the use of AI or agentic to drive true business value. Looks like Saurabh might start if he can figure out how to turn the mic on. We need an agent.
I think it
Could
was
we
turned
ask?
on, wasn't it?
It was.
We on?
Huh? We're planning.
Can you guys hear me? Okay. So the question was,
Gotta love it. Excited about most. Yeah, what are you most
what am I
excited
most excited about?
Yeah.
So one of the areas that I'm quite excited about is the intersection of agentic AI with smaller models. So when you think about agentic AI, you tend to think about large language models. You tend to think about ChatGPT. You tend to think about Claude, which is all great. I mean, they're all great reasoning models. But there's so much work going on with smaller models and fine-tuned models. And it's really interesting to see that sometimes the answer is not one big model. It actually may be a confluence of many models. And that might sound complex, but it actually might result in better accuracy and more and better cost control. So this is where some of the work that we are doing together with Intel and Red Hat is quite exciting. So that's an area I'm quite looking forward to.
Great. Dave, you got any
Sure.
thoughts? He's got his
think
own
I'm
lapel mic.
So just to kind of build on that, one of the slides I showed earlier was a timeline of from when data was available to identify an issue, to get the context, to make a decision, and how we've shortened that. I think back over my tenure at SAS with, first applying AI and analytics to the data to find those anomalies, but then to automate them, and now with agents and streaming analytics to be able to do that in real time, and the agents doing that for you to surface what are the issues and take action. So if a line needs to be shut down, or if something needs to happen to protect a worker, or whatever it might be, we've shortened that timeline down so much. I think that's what I'm most excited about is the benefits, the quality, the yield, the throughput, and the safety. We talked about worker safety. That's a big issue on the manufacturing floor, and if we can find those issues and nip them in the bud, that's a huge impact.
Brian, any thoughts?
Yeah, I think from my side, and I feel weird. I just feel like a little kid up here kicking my feet around. I'm too short. Gonna have to stop that. I think one of the things that I'm most excited about, I mean, Saurabh mentioned MCP and all these three-letter acronyms that I think from my side and the demo, if you do stop by the booth, and Saurabh was alluding to that, the decision loop there, it's pretty complex. I mean, there's a lot happening there, but it's made to seem very seamless. It's taking real-time sensor data, allowing a machine to ask its own questions of documents, and those documents are telling it what is the likely root cause. Well, that's the first step in the journey. The next step is, well, am I ready to execute maintenance around that root cause? And so you got spawn off multiple MCP tools to go pull in parts availability, resource availability, tooling availability. And all of those things have always been siloed. So for the industrial automation folks in the room, like OPC, back in the day where it didn't matter if you had a GE control or an AspenTech HMI or a Honeywell DCS, they were all isolated until OPC came along and it said, well, we're going to make it easier for these things to communicate. I think MCP is starting to do that for the agentic AI world. And you're going to start to see us accelerating and solving some of these complex problems because the implementation cost, I think, is going to go way down. Because everything's going to be able to talk through these sort of common frameworks in ways that we haven't been able to do, in sort of the AI world for many, many decades. So I think that the pace at which we can go.
Very good. All right, we have any questions from the audience for these gentlemen? Anyone? We got one over here, Emily.
They're recording, so they want us to wait for the microphone.
With regard to MCP, how are you applying governance to who has access to what data? So if multiple personas are accessing the same UI, but they have different levels of access to the data through normal governance channels, are you able to reduce what the MCP can return to those individuals based on persona?
Yes, so there's a couple of layers there. So each of the MCP servers have the responsibility of authenticating, right? So when you reach out into the MCP servers for a tool call, they'll authenticate. So that authentication is based on your enterprise's security policy. So that's one aspect of it. The other is when you construct an agent, at least in our application, we don't just give access to all the tooling to the agents. So you as an agent developer are actually deciding which tools does this agent need access to. So that's the other layer that allows you to be very explicit and declarative about what tools does the agent need access to. So those two put together provide a good level of governance around that.
Thanks, good question. Anyone else? Back there, Emily.
Hey, this is Nick Savage from Georgia Pacific. So thank you and sorry on behalf of the entire organization. But given, I mean, you guys were just talking about that RAM, the MCP, we've got A2A. A lot of this stuff is pretty new. I'm wondering if, given your proximity to some of that kind of work, you've got an idea of where we might be looking at going in the next 6 to 12 months?
Yes, I like this Q&A.
So, no, that's actually a really good question, and some of it is, I mean, we are figuring it out along with the rest of you. But I think there's a couple of things that are emerging. It's really easy to get started on something like RAG, right? So RAG is a good place to start with. It's using your knowledge base. There's proven techniques to actually vectorize your documents, and being able to just prompt these agents to give context-aware responses is a good place to start with. So that's one aspect of it. Where we are going a little bit ahead is trying to weave more deterministic logic inside agents, because as you can imagine, the core reasoning of agents is still stochastic because it's driven by a language model. But if it needs to make certain calls, how can you make that more deterministic? So I'll give you an example. So let's say if the agent needs to do a step like process refund, right? So process refund cannot just be an action that you ask the LLM to do. So we are actually looking at introducing concept called skills that actually encapsulate this logic block, if you will, right? And that makes it very deterministic, so you can actually code it, or you can actually say, okay, here are the 5 things that happen in a process refund. So I think one area that is happening right now, which is pushing a little bit more trust forward, is weaving in more deterministic logic inside these agents. And we are actually seeing that a lot from a roadmap request on RAM, so we are actually looking forward to incorporating that.
All right.
You don't need Wikipedia for doing most of the stuff. You just need the product. Is that what you meant by toning it down?
So there's 2 aspects of it, right? I mean, you don't need, you don't need, the question was, you not need Wikipedia, is that the analogy? So I think there's 2 aspects to it. So one is, exactly, so one is that you are able to bring in the knowledge base in your organization, which is the relevant one. So we actually allow you to bring documents from, wherever the documents are. You're able to organize the documents, so you know exactly this is my customer service document, this is my worker history document, and you can actually govern them so you can give the right level of access. So when you have a question, you know where to go to, right? So that's one aspect of it. What I was talking about more forward-leaning was that how do we make these agents less stochastic and more deterministic? So we are actually working a lot on ways to weave in more deterministic logic inside agents. So one natural way of doing that is with code, right? So you can do that. We actually support injecting Python code in agent logic. That makes it much more deterministic, but that's again a little bit more of a technical persona. But we're looking at a concept that we call agent skills that allow you to construct more of a logic block around, okay, here are the 4 things that need to be done to process refund. And then the agent has access to the skill, so you know that every time the agent calls that skill, it is exactly done the same way, and you will get the same output. So even though the overarching orchestration of the agent is done by a language model, you are rest assured that when it gets to that particular step, it is deterministic, it is repeatable.
We got a couple of questions.
Well, I have one more thing to add to, maybe not the roadmap, like where we're going, but the comment that that the ecosystem around MCP, LLMs, agents is moving at such an accelerated pace. Again, shameless, selfless plug for ourselves, but we are agnostic to that change. So not every LLM is good at the same things. I mean, some are better than others. You can see that, the proliferation. We don't lock you into just using Foundry or Bedrock or Anthropic. Use the right LLM for the right job. And it's the observability, and again, the M&D guy in me, that everything was a function of cost. Being able to see, well, it may take 20 seconds to retrieve an answer using this LLM because it's a little heavier, but it's a lower price point. Or my accuracy, I might trade a little accuracy for cost. So you get that full traceability. So that's been built in by design, and I think that's what I'm really excited about, because I haven't run into a customer yet that we've had these conversations that we can't adapt to what they're trying to do today, but also give them the confidence that where you want to be tomorrow and next week and next month, we're right there with you along that journey. And to Saurabh's point, I mean, we're spinning plates here. I use for folks that like Red Panda, that comes to the basketball game, spins the plates, tosses the bowls. That's a bit what we're doing at the moment, is we're spinning a lot of things, but I think we're doing it with purpose, and I'm excited by that.
Go ahead.
Yeah, I got two questions, really. Well, the big question I have in my mind is, have you considered taking this to NASCAR and running on their pit crew to see how they do? But I'll let you handle that. The two questions that I have, how do you go about drawing the line between an analog switch or using IoT or AIoT? Because you don't always have, not everything, at least in this environment, is going to be AI worthy of the question. It could be as simple as the temperature's at that point, turn the air conditioner on. We don't need AI for that. And the second question, this is a system guy, and where does it break when it breaks? I hope you don't think I'm being a naysayer by that. I think this is incredible technology. What do we need to focus on to prevent breaking?
Well, I'll answer the first question, maybe. Well, no. Well, I think we've had Formula One and others, so I think that's the more champagne version of racing. It depends. I'm from the South, so NASCAR is near and dear to my heart. For the analog, again, I'm a mechanical engineer, come from industry, and I go to a lot of the events, both our own and industry. And every conference you're going to go to is just talking latest and greatest, where things are moving. And people in the audience listen and think, well, that's what I need. I need some of that agentic AI. I mean, that sounds wonderful. And you might, but that might not be the starting point. And I think analytics is a continuum. And I always argue, let's sit down and figure out what problem you're trying to solve and how to do it most efficiently and most effectively for your organization. And I'll go back to, so Craig and I work together at GE. You have engineers that are this maintenance problem, getting alerts, needing context. I could build a better model that had better accuracy, it could detect more failures, but our fleet failure rates went up if I used a neural net versus a regression model, because the mechanical engineer sitting at the desk had no clue why the neural net was telling him there was a problem, so he didn't want to take the action. So it's a matter of trust. It's a matter of interpretability. It's a matter of what's the right tool for the right job. And that's not a linear one-line path. I think that's a multifaceted conversation that we have, and we'll welcome the conversation.
I think I'd add,
Oh,
I think I'm live. Double live. I think it's also about, maybe I'm not. I think it's also about kind of all of the above what Brian was saying. SAS is an analytics company, that's what we're well known for. And since our founding, that's been our focus. But we learned early on that data was critical. So data management is a huge investment for the company, more effective data management. But on the other end of it, model management and decision management, all are critical part of the whole ecosystem. So it's not just about the AI. Sometimes it's simple business rules. But being able to manage both through one decision engine is the key.
Yeah, these guys talked earlier about event stream processing and the ability to take very robust analytical models and push them out to the edge, right? Which sounds super exciting and you think big. But some of our first use cases around that was just streaming data management. Taking care of your data as it's being generated at the edge, offboarding what you don't need, taking data that is relevant to your problems and backhauling that. And so sometimes we have a tendency to not talk about the simple stuff, and maybe it's not evident that, simple business rules push to the edge or simple binary type decisions through an application like RAM can be handled as well. Oh, yeah, the what breaks question. Nothing breaks. No. I can say that. No, anyway. As far as what I'd say, maybe not what breaks, but what are the challenges that are, in that RAM ecosystem, right? Like, what are things that are hiccups that people are going to stumble upon, challenges when trying to implement it? Because, this stuff is new, right? We've got several customers under the belt that we're working with and having great results, but certainly there's a lot of learnings to happen because it's bleeding edge type stuff. Brian, you got some thoughts?
Yeah, well, I'd say, and maybe it's keying off of what Dave said earlier about governance and management, and I think that's what breaks. When you start putting stuff to production and you start to lose the lineage of what actions were taken on data before they fed a model, what model was running in production at the time of an event. How do you update? How do you revise? When the data starts to drift, how do you retrain? That's how things break. If you could consider that breakage, I think that's just part of the process. But it's how do you overcome that and put the guardrails in place so that you're prepared for it? You know it's coming, and the platforms and the capabilities that you make investments in need to have those guardrails in place, because things don't sit stationary. This is a very dynamic environment that we live in, and so you have to be responsive to that. I think some of it is accelerators and automation. So Steve in the back will be talking about some of the work at Georgia Pacific about doing these models at scale. That's the power that Georgia Pacific, it's like, you go talk to them and they're like, well, I need like 20,000 models in production. And we're like, what? What do you mean 20,000? And you start to go through the permutations. It's like, well, everything's personalized. And I can build the model for the first 5, but how do I go from 6 to 20,000? You've got to put automation in place, and that makes the retraining and the governance so much easier. And so there's automation, there's some tooling that we've made investments in to make that a little less arduous for customers.
Anything else to add, Saurabh? Or?
Yeah, so one area in terms of what breaks is, if you have a solid LLM driving an agent response, sometimes that response looks legit and it looks confident, and you tend to this is a great response. I should go by it. But sometimes you have to peel the onion to see what is exactly the response telling me. So what we have designed inside RAM, and I talked about, is this notion of experimentation. So you actually develop experiments or pipelines, and then there is a whole process around finding the champion pipeline that would actually be the one that's giving you the response. And the way you find your champion is based on what we call evaluations. And evaluations are a fancy way to say test cases, right? So the idea is that a subject matter expert, right? So it could be a technician, is designing your test cases. So the test cases could be a list of questions and answers. And they would go into the detail of, if I ask this question, I expect certain keywords. I expect bearing. I expect lubrication, things like that in the response, right? And then before you actually pick a champion, you would run those test cases, see which of your experiments did better, which one actually asserted the better percentage on those test cases. So that is the idea. So you're trying to prevent that because ultimately there is some level of opaqueness in the responses. You're trying to kind of get inside that.
I think we got time for one more, if anybody has final question. Okay, that's. All right, well, we will, we'll end. Thank you all for joining us here today. We hope we'll see you at the welcome reception in the Innovation Hub, 5:30 to 7. A lot of what you saw here in this presentation, we can show you in practice at our booth. There's a lot of other great presentations happening there as well. Again, you can scan the upper QR code there for a curated agenda of IoT-related presentations, demos, so on and so forth that are happening over the next couple days. If you don't have the event app yet, there's a QR code on the bottom to get you the event app. And that's about it. Thank you all. Good job, guys.